Elon Musk and NASA just shocked the entire space industry with this discovery. We look at the sun rising every day. It's bright, it's big, and it warms us up. Our sun happens to be the brightest object in our universe, one of its kind. It's natural we are really curious to know more about it, and curiosity always gives rise to exploration. And for the same reason, NASA has always been ahead in space exploration. From the Earth's satellite moon to its neighboring planets, Jupiter, Saturn, Uranus, and Neptune to name a few, NASA has been discovering outer space for a very, very long time. But have you noticed that we often tend to leave the solar planets, Sol, Sun, behind in the list? But not anymore. One of NASA's probes has been hovering around the sun for a while, and let me tell you, this is the closest that a man-made probe has ever been that close to the sun. So what terrifying information the probe has sent to Earth, and how does it manage to get so close to the heat ball? And how does any of this affect us? So many questions, aren't they? But don't worry, all of them will be answered till the end of the video. All you have to do is sit tight and stay tuned. Welcome to Genius's Guide, your daily dose of geniusness. Subscribe to the channel and like the video to show your love. If you're done with that, then let's dive in. It is said that our sun is an ordinary star, just one among hundreds of billions of stars in the Milky Way galaxy. But for scientists and space enthusiasts, this is not so ordinary. Why? Because being the only star we can observe in detail, it provides a basis for our understanding of all stars. But for today, we are fully focused on understanding only one star that happened to be the soul of the solar system, the Sun. The Sun formed more than 4.5 billion years ago, when a cloud of dust and gas called a nebula collapsed under its own gravity. As it did, the cloud spun and flattened into a disk, with our Sun forming at its center. The Sun is composed almost entirely of hydrogen and helium gas. Multi-million-degree temperatures in its dense core sustain nuclear fusion, providing the energy source for sunlight. The surface of the Sun is marked by colossal magnetic storms. The Sun's gravity holds in orbit a family of planets, moons, asteroids, and comets, the solar system. Do you know the Sun is so incomprehensibly big that it's almost pointless to bother trying to imagine its size? At about 864,000 miles, 1.4 million kilometers wide, the Sun is 109 times wider than Earth, and it accounts for more than 99.8% of the solar system's total mass. If it was a hollow ball, more than 1 million Earths could fit inside it. But the Sun isn't hollow, it's filled with scorching gases and soups of electrically charged particles called plasma. The Sun's surface is about 10,000 degrees Fahrenheit, 5,500 degrees Celsius, and it's 27 million degrees Fahrenheit, 15.5 million Celsius at the core. Deep in the Sun's core, nuclear fusion converts hydrogen to helium, which generates energy. There, hot plasmas rise and fall like the ooze in a lava lamp, which transfers energy to the Sun's surface, called the photosphere. Out beyond the Sun's photosphere lies the atmosphere, which contains the chromosphere and the solar corona. And the solar corona is what holds all the unanswered questions. The corona is the uppermost layer of the atmosphere that unleashes powerful streams of high-energy particles, known as the solar wind, which can be felt all across the solar system and far beyond Pluto. The wind blows about 280 miles, 450 kilometers a second throughout the solar system, extending the Sun's magnetic field out more than 10 billion miles. You might have wondered, what's the mystery here? It's in the Sun's temperatures that leave astrophysicists puzzled. At the Sun's core, it reaches a staggering 27 million degrees Fahrenheit. Its surface is a frosty 10,000 degrees Fahrenheit, which, as NASA notes, is still hot enough to make diamonds boil. Here's the weird part, though. Once you get into the higher parts of the Sun's corona, temperatures again rise to 3.5 million degrees Fahrenheit. Why so? Nobody knows, till, for the first time in history, a spacecraft has touched the Sun. It sounds unbelievable, isn't it? But it's true. NASA's Parker Solar Probe has now flown through the Sun's upper atmosphere, the corona. Wait, what? Let's take it slow. The Parker Solar Probe, PSP, is an exciting mission of exploration and discovery, a journey to the Sun itself. By flying into the Sun's outer atmosphere, the corona, the Parker Solar Probe will gather data on the processes that heat the corona and accelerate the solar wind, solving two fundamental mysteries that have been top priority science goals for many decades. This mission will transform our understanding of the sun and sun-like stars, enabling further exploration through our own solar system. Parker Solar Probe, touching the sun, is a monumental moment for solar science and a truly remarkable feat, said Thomas Zurbuchen, the Associate Administrator for the Science Mission Directorate at NASA headquarters in Washington. Not only does this milestone provide us with deeper insights into our sun's evolution and its impact on our own solar system, but everything we learn about our own star also teaches us more about stars in the rest of the universe. Just as landing on the moon allowed scientists to understand how it was formed, touching the very stuff the sun is made of will help scientists uncover critical information about our closest star and its influence on the solar system. Parker Solar Probe launched in 2018 to explore the mysteries of the sun by traveling closer to it than any spacecraft before. 3 years after launch and decades after first conception, Parker has finally arrived. The spacecraft moves at colossal speed at over 500,000 kilometers per hour, 320,000 miles per hour. The strategy is to get in and out quickly, making measurements of the solar environment with a suite of instruments deployed from behind a thick heat shield. At closest approach, the spacecraft will zip past the sun at 125 miles per second, protected by a carbon composite heat shield that must withstand up to 2,600 degrees Fahrenheit and survive blasts of radiation and energized dust at levels not experienced by any previous spacecraft. Yes, the thick heat shield is the reason behind the Parker probe to reach so close to the sun. Otherwise, it would have burst in flames within the seconds it entered, even in the millions of miles near the heat ball. 3 years after launch and decades after its first conception, Parker has finally arrived. At one point, as the Parker Solar Probe dipped to just beneath 10.5 million kilometers from the sun's surface, it transited a feature in the corona called a pseudostreamer. Pseudostreamers are massive structures that rise above the sun's surface and can be seen from Earth during solar eclipses. Passing through the pseudostreamer was like flying into the eye of a storm. Inside the pseudostreamer, the conditions quieted. Particles slowed, and number of switchbacks dropped, a dramatic change from the busy barrage of particles in the spacecraft usually encounters in the solar wind. For the first time, the spacecraft found itself in a region where the magnetic fields were strong enough to dominate the movement of particles there. These conditions were the definitive proof the spacecraft had passed the Alphen critical surface and entered the solar atmosphere where magnetic fields shaped the movement of everything in the region. The first passage through the corona, which lasted only a few hours, is one of many planned for the mission. Parker will continue to spiral closer to the sun, eventually reaching as close as 8.86 solar radii, 3.83 million miles, from the surface. Nicola Fox, Division Director for the Heliophysics Division at NASA headquarters, said, "I'm excited to see what Parker finds as it repeatedly passes through the corona in the years to come. The opportunity for new discoveries is boundless. We are excited too. Parker Solar Probe will revolutionize our knowledge and understanding of coronal heating and of the origin and evolution of the solar wind. The data will also help us answer critical heliophysics questions that have puzzled scientists for decades. Are you excited? If yes, comment down your insight below." So this was it for today, guys. Hope you liked the video. Make sure to smash the like button and subscribe to the channel for us to provide you with more must-know developments in finance and technology. We'll see you in the next one. Until then, peace.